Hello to you once again. You're welcome to the channel. And this is one final tutorial on our reduction to separable of homogeneous differential equations. So with this example, we've looked at how to detect whether a differential equation is homogeneous, and we've looked at how to reduce it into separable. So we are going to apply both knowledge here. So first of all, we know that to test whether it is homogeneous, we have to find f of lambda x, f of lambda y, and it must be equal to lambda raised to a certain degree times f of xy. So that's what we are going to do here. So in doing that, I'm going to have lambda x dy being minus lambda, what's again here? Lambda y dx minus square root of lambda x all squared minus lambda y all squared dx, and is equal to 0. Okay, and the next thing we are going to do, so we can see that we have lambda x dy minus lambda y dx, and this is we are going to try to expand it. So we have lambda square x squared, we have lambda square y square dx or dy is dx equal to 0. Then in our bracket we can decide to what? Factorize lambda square. So we are going to have lambda square multiplying x square minus y square dx equal to 0. So to prevent my solution from being too lengthy, we know that this term here, let me use another color, that this term here can be written as square root of lambda square times square root of x square minus y square. Okay, and we know square root of lambda square will just give me what? It will give me lambda. So we'll end up with lambda x dy minus lambda y dx minus lambda multiplying x square minus y square dx equal to 0. So we can see that all our terms are homogeneous to the first power. They are all homogeneous to the first power. So where our n is equal to 1. So we've determined that our differential equation is homogeneous. So on the next page, we are now going to reduce it to separable. Let me rewrite it again. X dy minus y dx minus square root of x square minus y square dx being equal to 0. Let me write this well. Minus y square. Okay, so we know our y is equal to xv, and our dy is equal to x dv plus v dx. So we are going to perform our substitution here. We'll end up with x multiplying v dx plus x dv minus y dx is just going to be xv dx, and it's going to be minus square root of x square minus xv squared dx. Sorry, my space is limited, being equal to 0. Okay, so the next thing we are going to do is try to expand it. So in doing so, we are going to have trying to find a way to cancel out my x's. Okay, so that's what we are going to try to do here. So let's see how it's going to be done. So here I see I have x squared minus xv squared. So I can factorize x squared out and have 1 minus v squared dx. Okay, 1 minus v squared dx being equal to 0. And from our example, we can see here becomes, let me rewrite everything, v dx plus x dv. This is v minus x v dx minus, here it now becomes x multiplying 1 minus v squared dx equal to 0. So we continue. Now we can see I can divide through by x. I can divide by x. So x. So I'm just going to be left with v dx plus x dv minus x, no, I've cancelled that x, minus v dx minus square root of 1 minus v squared dx equal to 0. Okay, so after that we can see we have v dx and we have minus v dx, so they will also cancel out, and our solution becomes x dv minus square root of 1 minus v squared dx equal to 0. So it is now separable. Okay, so we can group similar variables now. So I can divide through by square root of 1 minus v squared, and before that, let me just move it to my right hand side. So we have square root of, it's better to get rid of the negative sign for your work to be simpler. So we divide, this comes here, this goes here. So we'll end up with 1 over square root of 1 minus v squared, and it is equal to 1 over x. We have the v here, sorry. It's equal to 1 over x dx. And now we integrate. So in integrating, we have 1 over 1 minus square root of 1 minus v squared. Looks like the derivative of sine inverse. Okay, it looks like the derivative of sine inverse. So it means the integral becomes sine inverse of v. Okay, and here 1 over x is just on ln x. And remember, we add our plus ln c. And moving forward, we can see it now becomes sine inverse of v equal to ln xc from our laws of logarithm. And we know our v to be, you know y to be xv. So v will be y on x. So substituting it here, we have sine inverse of y on x being equal to ln x. Okay, and we can my page is finished, so we can leave it like this, or we can introduce our e exponential function, so that we'll end up to get e sine inverse of y on x will be equal to xc. And you can go ahead to make c the subject or make y the subject, but that's beyond the scope of this tutorial. So this is how you can solve or reduce a homogeneous differential equation to separable and find your general solution. Thank you. Bye bye.